Hi, how is it going? Welcome to Code with Z. Today's question is LeetCode number 34. Find first and last position of element in a sorted array. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're given an array of integers called nums, and it's sorted in non-decreasing order, so basically in ascending order. And we gotta find the starting and ending position of a given target value, basically the index. So for example, if we check the examples here, we're given this array and our target number is 8. And the output, the thing that we should actually return, is gonna be 3 and 4. Why? Well, let's check. We're looking for 8 inside of this array. And when we find it, we're gonna return the index of that position. So let's check. This is the index of 0, 1, 2, 3. Well, would you look at that? This is actually 8, which is equal to our target number. So we're gonna return the index of it. That's gonna be 3. And then we're gonna keep on looking. Oh, this is also another 8, and the index of this one is gonna be 4. And then at the end, we're gonna return these inside of an array. And if we look for a number that doesn't exist inside of our array, we're gonna return -1 and -1. Now we could basically just loop through the array and actually come up with a result, and that would be super easy, but the issue is we gotta solve this problem with the time complexity of log of n. And if we loop through each element here, that's gonna give us a time complexity of n, and we don't want that. Alrighty, let's solve this together, and I want you to know that I won't finish this video until I make sure you fully understand how to solve this problem once and for all. Building these slides took me ages, but I hope it provides you with value. Now, this is our array that was given to us, and this is our target number, and we gotta find the index and the position of this target number inside of this array with the time complexity of log of n. Now, I don't know about you, but for me, each time I hear about searching, a sorted array, and a time complexity of log of n, I immediately think of binary search, because binary search always gives us the time complexity of log of n when we're given a sorted array. And this is a sorted array, as you can see. But binary search can only find one number inside of the array. It can't find two numbers, but we currently need two numbers. Well, let's see what will happen if we apply a normal binary search to our array here. In binary search, we have three important variables. One is called left, and that's going to be equal to the index of the first element inside of the array. And as you can see, the index of this number is 0, so left is going to be equal to 0. And the other one is called right, and that's going to be equal to the index of the last element inside of the array. And when we have these two, we can actually calculate another variable called mid. And this is basically the middle between these two. Now, I'm just currently explaining the thought process, and then I'll show you the structure of the algorithm, and then I'll visualize all of the algorithm. So don't worry about anything. When we calculate this mid variable, it's going to be equal to the index of this element in the center, right? And each time we calculate this mid variable, we're going to be like, is the number that our mid variable is pointing to, meaning this 7, equal to our target? So is 7 equal to 8? Now, really, if it was actually equal to 8, that would be awesome, because that would be our answer in a normal binary search, right? But as you can see, 7 is not equal to 8. So we're going to ask, is 7 less than 8? And the reason we ask this is because our array is sorted, as you can see. So if the number that's in the middle, right, is smaller than the target, that means all of the numbers that come before the middle number are also going to be smaller than the target, and we can just ignore them because the array is sorted. So we're going to be like, is 7 smaller than 8? Well, yeah. So we're going to be like, all right, so we know that we won't find our answers here because all of these numbers are going to be smaller than the middle number, and the middle number itself is already smaller than the target. So we don't want any of these. So we're going to be like, let's ignore all of these and let's make left be equal to middle plus 1. Like so. As you can see, we've ignored all of these, and then we're going to calculate our middle again. And this time our middle is going to be pointing to this number here. And we're going to ask, is the number that our middle variable is pointing to equal to the target? Well, yeah, 8 is equal to 8. That's awesome. And we're going to return mid because this is the position of the number that we actually look for. Now, this was a normal binary search and it works perfectly, right? But the thing is, we also have to return the index of this 8 here. We have two 8s in this array. So because binary search works so perfectly, we're gonna use it, but we're gonna make some tiny, simple modifications to it. So let's bring our array to this part so I can explain the structure of the algorithm, which is basically just a binary search with a simple modification. So I think we can all agree that we need to return something, right? So let's define a variable called result, and this is going to be equal to -1. Why -1? Because the question itself told us if we can't find any answers, we're going to return -1. And then we're going to have our binary search variables. So we're going to have left, that's going to be equal to 0, just like we saw in the previous slide. And then we're going to have right, that's going to be equal to the index of the last element inside of the array, nums.length, meaning the length of this array, that's going to be 1, 2, 3, 4, 5, 6. So nums.length is 6, -1, that's 5. So right is equal to 5, and the number with the index of 5 is gonna be this number. So basically the same thing that we saw in the previous slide. And then we obviously have our target that we have to look for inside of our array, and we're gonna have one tiny simple thing extra, and that's gonna be search left, and we're gonna initialize it to true. Now, what does this even mean? Well, here we're gonna be like, binary search was so awesome and it worked perfectly, right? So because we have two answers, why not use binary search to look for one of the numbers, and when we find it, we're gonna again use binary search to look for the other number. It makes sense, right? Binary search works for one result, so we can apply two binary searches and we're gonna get the two results that we want. But the first time that we run our binary search, we're gonna look for the leftmost answer, meaning the answer on the left side. And then when we find it, we're gonna look for the rightmost answer, and that's gonna be this one, because we can all agree that this is on the left side and this is on the right side, right? So in the beginning, we're gonna be like, let's find the left side result, and then let's find the right side results. Again, don't worry, I'm just currently explaining the structure, and then I'll visualize everything and you're gonna see with your own eyes how everything works. So because this is a searching algorithm, we obviously need to have a loop. This is gonna be representing our loop, and anything inside of this is gonna be basically inside the loop. And we're gonna keep on looping as long as left is smaller or equal to right. So this is our loop condition. As long as this is true, we're gonna keep on looping. As simple as that. Inside of our loop, we're gonna calculate mid. Just like we saw in the previous slides, we're gonna be like left plus right divided by 2 is going to be equal to mid, because mid is basically in the middle of left and right. And when we calculate mid, we're going to ask, is the number that our middle variable is pointing to equal to our target? Literally the same thing we saw in the previous slide. So if these two are equal, we're going to be like result is equal to mid. So we're going to update this value here, and result is going to be equal to the value of middle. All of this is still normal binary search, right? And then after this, we're gonna be like, if search left is true, meaning if we're looking for the leftmost answer, right should be equal to mid -1. Now, what does this mean? So we're gonna be like, even though we found our answer, even though nums of mid is equal to target, we're gonna store it inside of our result variable, but we're still gonna check if this is the leftmost answer because our search left is true. So we wanna make sure that if, for example, we are here, no other answers exist to the left of our current answer. And as you can see here, it does. Like if we come across this number and if we check its left side, on the left side, we have another answer, and we wanna make sure that we actually find this number. And else, meaning if search left was false, so if we were looking for the rightmost answer, we're gonna be like left should be equal to middle plus 1. So for example, if this is our middle and this is our answer, we need to make sure that no answers exist on the right side of it. And if we check here, we do have an answer. And this is basically it. These two lines are gonna make sure that we find the leftmost answer and the rightmost answer. And this line is basically part of the binary search itself. We're gonna be like, is target smaller than the nums of mid? So if our target is smaller than the middle number, we obviously don't need to check the right side because our target is smaller than the center. So we're gonna say right should be equal to middle -1 because we don't wanna check the right side. We know our target is smaller than the number that's in the center. And else, meaning if our target was greater than the center, we know our answer is not gonna be on the left side. So we're gonna be like left should be equal to middle plus 1 because we wanna ignore all of the numbers that are actually prior or before our center, or before our middle number. And then at the end, we're gonna return our result. Now let's visualize everything. So in the beginning, our result is gonna be initialized to -1, and then our left is gonna be equal to 0. And nums of 0 is gonna be pointing to this number. Again, just like we saw in the previous slides. This is the number with the index of 0, and because the left is equal to 0, nums of left is gonna be pointing to this number here. And then our right is gonna be equal to nums.length -1, meaning 6 -1, and that's gonna be equal to 5. So our right is going to be pointing to the number with the index of 5, and that's going to be this number. And then we're going to enter this loop, and we're going to calculate our mid. We're going to say left, which is 0, plus right, which is 5. 0 plus 5, that's going to be 5, divided by 2, that's going to give us 2.5, right? And because we don't want decimals here, because this mid is going to be representing the index of the middle number, right? We're going to ignore the decimal and we're going to keep 2. So middle is equal to 2. And the number with the index of 2 is going to be 0, 1, 2. So this number. So our middle variable is pointing to this number here. Then we're going to be like, is nums of mid, meaning 7, equal to our target, meaning 8? Well, no, 7 is not equal to 8. So we're going to ignore all of this. And we're going to check if target, meaning 8, is smaller than 7. Well, 8 is not smaller than 7, so this statement is also false, and we're not going to get inside of this if statement, and we're going to fall inside the else, and we're going to say left should be equal to 2 plus 1, because our mid is 2, so 2 plus 1, and that's going to make left be equal to 3, and because now left is equal to 3, it's going to be pointing to the number with the index of 3, which is going to be this 8 here. And then we're going to keep on looping, because left is 3 and right is 5, so left is smaller than or equal to right. So this condition is true, and we're gonna keep on looping. Again, we're gonna calculate middle, so 3 because left is equal to 3 plus 5 because right is equal to 5. That's gonna give us 8. 8 divided by 2, that's gonna be 4. So middle is gonna be pointing to the number with the index of 4, and that's gonna be this number here. And then we're gonna be like, is 8, so is nums of mid, meaning 8, equal to our target? Well, our target is 8, and 8 is equal to 8. So this statement is true, and we're going to enter this if statement. And we're going to be like, result should be equal to mid. Well, mid is 4, so result is going to be equal to 4. And then we're going to ask if search left is true. Well, yeah, it is true. So we're going to be like, all right, even though we have an answer, let's check the left side. So we're going to be like, bring right to the left. We literally say right, which is pointing to this number here, should be actually pointing to one number prior to middle. So basically this number here. So right is going to be equal to 4 minus 1, and that's going to make right be equal to 3, and it's going to bring it from here all the way to here. So now both left and right are pointing to this number, and we're going to keep on looping because left, which is 3, is smaller than or equal to right, which is also 3. So this condition is true, and we're going to be like 3 because left is 3 plus 3 because right is also 3. That's going to give us 6. 6 divided by 2, that's going to be 3. So middle is also going to be equal to 3, and it's going to be pointing to this 8 here. And then we're going to be like, is nums of mid, meaning 8, equal to our target, which is also 8? Well, yeah, this is true. So we're going to be like, awesome. Enter this if statement and update result to be equal to mid. So now result is going to be equal to 3, like so. And then we're going to be like, is search left true? Yep, it is. So we're going to be like, all right, right should be equal to mid minus 1. So that's going to make right be equal to 3 minus 1. That's going to be 2. And now right is equal to 2. And we want to keep on looping. But if we check, left is not smaller than or equal to right anymore, because left is actually greater. Left is 3 and right is 2. So we're not going to keep on looping, and we're going to return our result, which is 3. And if we check, 3 is the index of the leftmost answer. Now, what about the rightmost answer? Well, you are completely right. We have to run this function again for the right side. So we're going to call the same function again, but we're simply going to make search left be equal to false, and that's it. Now let's code this in the simplest way possible. Alrighty, let's code this together. So we all saw that we need to run binary search twice. One is going to find the leftmost answer, and the other one is going to find the rightmost answer. So because we don't want to repeat ourselves a lot, we're going to actually turn this into a function, and we're going to call it binary search. And this is going to look really familiar because it's going to take in left, right, and search left, like so. And then we're going to enter this function. We're going to implement everything we saw inside of this function, and then at the end we're going to call it twice. So in the beginning, we obviously need to have a result variable, and that's going to be equal to minus 1, just like we saw in the slides. And then below this, we're going to have our loop. We're going to say we want to keep on looping as long as left is smaller than or equal to right. And then we're going to enter this loop, and we're going to say, well, we need a middle variable, right? So let's calculate that. We're going to say let mid be equal to left plus right divided by 2. But in case we have decimals, we want to get rid of them. So we're going to wrap this around math.floor. And that basically gets rid of the decimals that we might actually encounter. And now that we have our middle, we're going to be like, if nums of mid is equal to our target, do the following. So we're going to enter this if statement and we're going to say result should be first of all equal to mid, because we want to store the index that we actually found. And then we're going to say if search left, meaning if we want to find the leftmost answer, is true, do the following. Because search left is true, that means we need to look for the answer on the left side. So we're going to be like right should be equal to middle minus 1. So we're going to be like right, come to the left side. And if this was not true, meaning if we were actually looking for the answer on the right side, we're going to bring left to the right side. So we're going to be like left should be equal to mid plus 1. Now we're basically done because this part takes care of everything. And now we only need to have the else if statement of binary search itself. We're going to say if target is smaller than nums of mid. So if we didn't find the number that we were looking for and our target was smaller than the number in the middle, do the following. Here, because our target number is smaller than the number in the middle, we're going to be like right, come to the left side because obviously you don't have the answer. So we're going to be like right is equal to middle minus 1. And else, if the target was actually greater than the number in the middle, we're going to be like left should be equal to mid plus 1. Now let me zoom out a little bit so we can see our code in a more clear way. This is all of our function, and when we are done, we wanna return our result. Literally after our while loop, after we're done with the loop, we wanna return our result. Now this is our binary search function, so let's call it. We're gonna be like const leftmost answer is equal to binary search, and we're gonna have to give it left, right, and search left. So we're gonna say left is equal to 0, right is equal to nums dot length minus 1, and search left should be true because we're looking for the leftmost answer. And then we're gonna copy paste this, and we're gonna call this one rightmost answer, like so. And because it's rightmost answer, we're gonna make search left be equal to false. And at the end, we're gonna return leftmost answer and rightmost answer, like so. Now let's run it and see if we're gonna pass our tests. It would be really funny if we didn't. Yep, as you can see, all 3 are accepted. Now let's submit it. Moment of truth. Drum roll, please. I'm just kidding. Let's see. Yep, accepted. That's awesome. Let's analyze our time complexity. It should be log of n. Yep, it is. Even better. Thanks for watching. Don't forget to like and subscribe and keep on coding.